They were hoping that President Obama would hear her words tonight if we could get them read on air. So she gave me a letter, and unfortunately there were too many people at the wake for me to get up to actually see the family, so the letter was passed back to me.
Okay.
But this is what she wrote, and if you could read it, because I can't.
Okay. The family gave permission.
The family wants, they told me to bring it to you.
Okay. It says, my name is Natalie Barden, and I wanted to tell the president that only police officers and the military should get guns. If people want to do it as a sport, then they could go to a shooting range, and the guns would not be able to leave there. So that's what she wants President Obama to hear.
She wants, yeah, this is what the question she wanted to ask him.
What's your problem? I said, what's your problem?
How are you today, sir?
Okay, how's it going?
Fine, thank you. Thank you, sir.
There are no limits.
It figures it would be something like this.
Our nation, our ideal of vision.
Excuse
We don't want
me.
to just survive.
You
We
know,
want to
you look like your head
succeed.
fell on the cheese dip back in 1957. You're okay. This one, real fucking ugly. You see, I take these glasses off, she looks like a regular person, doesn't she, huh? Put them back on, formaldehyde face. That's what we got.
That's enough out of you. You get out or I call the cops.
Call the cops. You know what you need? You need a Brazilian plastic surgeon.
I've got one that can see.
He's a tall, Caucasian male, doesn't appear armed, wearing sunglasses.
I don't like this one bit. Not one.
What really happened on that Thursday here at Augusta High School that led to Chris Wood's death?
The fuck is that? Shit! I'm dying in this fucking country-ass fucked up town. Shit flying in my mouth. The fuck? I can't see pollen. Let's get the fuck out this country, motherfucker. I can't even see me.
Chris Wood's death.
I think it'll be useful for us to try to stand back a little bit and get a perspective of what we think of as reality. And we'll use as our springboard verse 12 of chapter 6 of Ephesians, where Paul tells us we wrestle not against flesh and blood, but against principalities, against powers, against rulers of darkness of this world, and spiritual wickedness in high places. That's scary stuff if you realize what it's saying. We're not against flesh and blood. You and I can relate to that. We're talking here a whole list of things that are actually ranks of angels, fallen angels at that, and some of them are demons. We take the view that fallen angels and demons are not the same thing. Fallen angels are vastly more powerful. They can materialize. They can engage in combat, among other things. Demons are powerless except to the extent they can influence, possess, and guide, and they seem to be very desperate for embodiment. But be that as it may, that's the details of that for a subject for another time. Let's talk about the boundaries of reality. Let's take puny man and put him right in the middle. If we take size as increasing to the right here, the cosmos is the exploration of things bigger than ourselves. That leads us into studies of largeness, the universe itself. That leads to astronomy, astrophysics, those kinds of things. And the great discovery of 20th century science is it's finite. It has a limit. That the cosmos is it's not infinite. The universe has a finite limit. It might be expanding, yes, maybe, but it's finite, not infinite. Big discovery, profoundly significant. We're going to look at the other direction for a little bit, towards smallness. In fact, we get so small, we'll be talking about hyperspaces. That's a fancy word for meaning spaces of more than 3 dimensions. We think of 3 spatial dimensions. We'll talk a little bit more about that in a minute. But we're really going to explore the limits of smallness. Did you realize there's a limit to smallness? Most of us think we can make something, whatever we've got that's small, we can cut in half and make it even smaller. Not true. This leads into the area of what's called quantum physics, subatomic particles and the like. We discover, shockingly, that the universe that we know, the physical world that we know, is made up of units that are indivisible. You can't split them up. You can't get smaller. And the implications of that are staggering. There are quantum physicists that committed suicide as they came to grips with what the implications that are. Let's back up for a minute and let's talk about the smallest thing you and I have the capacity to imagine, and that's an atom. We've all had atomic sketches in school. We think of an atom, the simplest one would be the hydrogen atom. It has a nucleus. Around that nucleus is orbiting, apparently, an electron. Okay? So we have a nucleus in the middle and electrons spinning around it. This is not to scale, but I do want to get across to you what the scale would have to be to make this legitimate. We know that the nucleus is about 10 to the minus 13 centimeters. The atom itself has a radius of, or a diameter, I think, a diameter of 10 to the minus 8 centimeters. Now you say, well, I can't relate to those small numbers. You don't need to. You just look at the ratio of them. In other words, if the atom is 10 to the minus 8 and the nucleus is 10 to the minus 13, that means then that the ratio of those is 100,000 to 1. See, in other words, 13 to the 8, that's the number of zeros. So you 10 to the minus 8 is 0.00000, 8 of those zeros, 0.1, and the other one is 13. So the difference between those two is 5. You take the difference. In exponents, you take the difference. You with me? Okay. So the ratio of those is 10 to the 5th, 100,000 to 1. The atom is 100,000 times in radius or diameter, either way, of the nucleus. Now that's linear. If we're going to do a 2-dimensional diagram, you got to square that. It's square feet in area, right? If you're going to do it in volume, it's cubed. It's 10 to the 5th by 10 to the 5th times 10 to the 5th. In other words, your 10 to the 5th has to be, if you're going to go volumetrically, that's cubed, right? If I have a foot length in area that would be 1 square foot, foot by foot. If it's cubically, it's a foot by foot by foot, right? If it's if it's a yard, it's 3 feet. Square, it would be 3 by 3, right? 9 square feet. That's 27 cubic feet in a cube. You with me? You cube it. Well, so volumetrically, the volume of material there is 1 part in 10 to the 15th. Well, what does that mean? Okay, that is a ratio of 1 second to 30 million years. 10 to the 15th is a mathematical way of expressing a very large number. 1 second to 30 million years. Let me give you a practical example of this. I have a podium here, okay? And if I said that this is solid, boy, it sure feels solid. That's my podium, right? Is this solid? I say it's solid. Mary over here says, you're all washed up. There's nothing here. She is more right than I am by that ratio. Is this all really just empty space? If she maintains this empty space and I say it's solid, conjecture number 2 is more descriptive than number 1 by that same ratio. The ratio of 1 second to 30 million years is 10 to the 15th. What's my point? This world that we think of as being real is a simulation. It turns out to be an electrical simulation. It pretends to be real. It feels real because the orbits of the electrons and the atoms of my hand are colliding with the orbits of the electrons that make up it feels solid. It sounds solid. All those physical attributes do occur, but they come from an electronic simulation. You and I are in a virtual environment. Let's go look at this a little further. We discover in modern science that everything we know is made up of indivisible units, units that cannot be divided, whether you're talking about mass, energy, length, space, what have you. If I take a line of anything, let's just imagine I take a line here, I can obviously cut that line in half, can I? I can take the half and take it, and I can cut it in half, right? And whatever I have left, I can cut that in half. And you'd think that I could do that forever. I might get so small, I'm just dealing conceptually. But whatever I've got left, you think, well, no matter how small it is, I can cut it in half. It turns out that's not true. One of the shocking discoveries in science is you get to a point where if you try to divide it again, it loses a very interesting property. It loses a property the physicists call locality. It suddenly becomes everywhere at the same moment. It loses locality. Now, you and I can't deal with that. But it turns out that that's called the Planck length. In length, it happens to be 10 to the minus 33 centimeters. If I get down to 10 to the minus 30, that's very, very tiny. But if I get down that small and try to divide it, it's everywhere at once. They've discovered that every photon in the universe knows what every other photon is doing right now, immediately. There's no transmittal. Ooh, what does that mean? There's a thing called Planck time. There's a period of time that you cannot divide any further. The shortest period of time is 10 to the minus 43 seconds. That's called Planck time. It'll just take a second. Okay, you got 10 to the 43 zeros Planck times left. That's a lot. No, it's a very small unit of time. I believe that's the twinkle of an eye, by the way, in the Bible. So the point is, there is a limit to smallness. And that's a shocker. At the macrocosm, we know we're limited. The universe is finite. In the microcosm, it's finite. That has staggering implications for every one of us. We have a universe that has finite limits at both ends. It can't get any bigger, and you can't get smaller than these units. So that means we are in a simulation, and we are in a digital simulation. These are not, there's no such thing truly as analog units. They're digital. They are made up of indivisible elements. Scientists have become concerned that the constants of physics appear to be changing. And there was an article in Scientific American back in June of 2005 on the subject. But the conclusion, the reason scientists are so concerned about the fact certain constants may be changing is because if they are, and they apparently are, it implies that our unit, their words, not mine, our universe is but a shadow of a larger reality. Wow. Just because the constants aren't constant, they come to this conclusion, it turns out. That's what the Bible has said all along in Hebrews 11:3, 1 Corinthians 15, and elsewhere. Let's take a look at what Paul said to the Ephesians in chapter 3. He's speaking about Christ dwelling in your hearts. He said that Christ may dwell in your hearts by faith, that ye, being rooted and grounded in love, may be able to comprehend with all saints what is that breadth, length, depth, and height, and to know the love of Christ which passes knowledge, that ye might be filled with all the fullness of God. Okay, he's making his point, but whoops, did you notice what he did along the way? That comprehend with all saints what is that breadth and length and depth and height. Paul, whether he knew it consciously or it was just the Holy Spirit, there are 4 dimensions of the universe. Einstein's theory of relativity is the great discovery of 20th century science, discovering that we live in 4-dimensional space, not 3. 3 spatial dimensions and time. It's a physical property. You need to understand that if you're going to understand your Bible. We've just gone beyond Euclid. You and I had Euclidean geometry when we were in school. But in 1854, George Riemann introduced metric tensors. It took 60 years before people could apply it. It took 60 years for Einstein to use that mathematics to develop 4-dimensional space-time. And he went to his death frustrated because he couldn't go further. He couldn't reconcile certain things that Kaluza and Klein in 53 did, doing exactly what Einstein did, adding 1 dimension. And they reconciled light and supergravity, and Yang-Mills went in 63, a decade later, and reconciled electromagnetic and both nuclear. So the 4 main forces are now reconciled, at least in part. Since 1984, most thinkers in this region of quantum physics believe in 10-dimensional superstrings, that we live in 10 dimensions. And I think that happens. I'm not trying to get you into mathematics except to point out that Nachmanides, a Hebrew sage in the 13th century, by studying the text of Genesis, came to the conclusion that our universe has 10 dimensions. 4 of them are directly knowable, 6 are not knowable. And he published that to that effect. And now in modern, the 20th century physics, the particle physicists have discovered that we live in 10 dimensions. 4 of them are directly measurable, 3 spatial dimensions in time, and 1 of them, or I should say 6 of them, are curled less than 10 to the minus 33 centimeters, and thus are inferable only indirectly because they're small in the wavelength of light. So the point is, we've spent millions of dollars on atomic accelerators to discover what Nachmanides discovered by reading the text. I think that's kind of fun. But let's shift gears now, having perhaps humbled ourselves a little bit about our perceptions of reality, what is really real. We read in the Bible the spiritual world. We tend to think of this as the real world. The spiritual world is this fuzzy thing out there. No, it's the other way around. The spiritual world is the real world. We are in a special subset of it. That's the point.